While performing brain surgeries, it is a common practice to keep the patient awake throughout the operation. While the thought of being awake while someone pokes around at your brain is certainly displeasing, this practice allows surgeons to have a complete feedback loop while working in vital areas. If a surgeon is unintentionally making a mistake, the patient can simply describe any negative sensation that they're feeling. For example, when repairing nerve tissue across the body or when performing surgery on the spinal cord. These procedures often require a surgeon to make deep or otherwise painful incisions. For the patient, being awake is just not an option. But how can a surgeon get a similar feedback loop in order to avoid making mistakes? Introducing TickleSense. TickleSense uses real-time or recorded electroencephalogram data of a patient's brain who is under anesthesia in order to detect tickling sensations from across the body. The idea is simple. While performing surgery in an area, the surgeon can simply tickle the unconscious patient and use TickleSense to ensure that nerve signals are still reaching the brain, therefore preventing the risk of medical error. But why tickling? Simply touching the patient won't induce a strong enough response in the brain, and while inflicting pain on the patient does reflect in the brain's electrical activity, tickling is a much safer alternative. It is a very distinctive EEG reading which remains relatively unchanged even when a patient is under anesthesia. It's a creative solution to a problem which might otherwise require expensive technology or professional expertise. So how does TickleSense work? TickleSense uses a patient's EEG data over the course of a surgery, but the raw data is hardly useful. Instead, TickleSense performs a custom-built spectral analysis of the EEG data using Fourier transformations in order to derive electrical activity at specific wavelengths in real time across 32 different regions of the brain. This spectrogram is given to a custom convolutional neural network built with TensorFlow, which has been trained to determine if the patient is being tickled or not, as well as if the patient is under anesthesia. The model has over 92% accuracy. The result is then displayed in real time by TickleSense's modern user interface, along with the EEG spectrogram and EEG readout. TickleSense has been deployed to Netlify, including the machine learning pipeline. Since it is a web app, it can be easily integrated into a procedure room on most devices. You can even try TickleSense's demo with sample EEG data via the link attached to this submission.